In this problem, we have 3 randomly selected households surveyed, and the numbers of people in the households are 3, 5, and 10. So we're going to take samples of size n equals 2, so that means just take 2 at a time. We're randomly selecting with replacement from the population of 3, 5, and 10. So we want to find all possible pairings, and they actually give this to us in the problem down here below. So what we want to do is determine what proportion of the values in each group is an odd number. So in the first group we have 3 and 3, so 100% of the values in that group are odd. So I'm going to figure this out for each pairing. So we've got, let's do this. So for 3, 3, we've got 100%. For 3, 5, we have 100%. For 3, 10, we have 50%, because the 3 is odd, the 10 is not. And then 5, 3, and 5, 5 are both 100%. I'm just listing these down below. And then 5, 10 is 50%. 10, 3 is 50%. 10, 5 is 50%. And 10, 10 is 0%. So what I'm going to do now is construct the probability distribution table by choosing each of these individual values. So I've got 0, 50, and 100%, and we're going to write those as decimals. So it's going to be 0, 0.5, and 1. And then what's the probability of each one? Well, there's 9 values, so since the 0 only shows up one time, that's going to be 1 over 9. 50% shows up 1, 2, 3, 4 times, so that's 4 over 9. And then the 100%, there's 4 of those, so that is also 4 over 9. So that's my probability distribution table. So now we can go on to the next part. So here you can see those values are filled in here. Now the question is the proportion of odd numbers in the population equal to the mean of the sample proportions? And yes, that's the case here. How do I know? Because how many out of the group 3, 5, and 10 are odd? So 3 and 5 are odd, 10 is not. So that proportion is 2/3. Now, if I look at my sample proportions and probabilities, I can actually just go ahead and multiply, and I get 0, multiply 1/2 times 4/9, I get 2 over 9. Multiply 1 times 4 over 9, and I get 4 over 9. And if I add all those up, I get 6 over 9, which is 2/3. So since those values are the same, that's why I know that the proportion of odd numbers in the population is equal to the mean of the sample proportions. Now I could put those proportions in list 1, 0, 0.5, and 1, and list 2, make that 1/9, 4 over 9, 4 over 9, and then use my one variable statistics in order to find the mean. But in this case, it's fairly easy to do by hand, so that's why I did it by hand. We have one more question, and that is which is correct, and it's that the sample proportions target the proportion of odd numbers in the population. So sample proportions make good estimators of the population proportion. So they came out the same, so we would say that sample proportions are good estimators of the population proportion. And that is the end of that problem.